Hi everyone, welcome to the Thursday and Friday video lesson for November 19th and 20th. So today we learned about the crisscross rule, which is a wonderful shortcut when you're balancing ionic compounds. We did a little bit of practice on how to name ionic compounds when there's that variable charged metal. And then we had about 20 minutes or so of independent work so you could ask questions and get your assignments in. But first, let's start with our warm-up. So I gave you guys 3 different pairs of ions, and you need to give me the balanced formulas. So here, the first one is Na with a positive charge of 1 and oxide with a negative 2 charge. So if I'm doing the math, I can see that I have 1 minus 2. So this gives me an overall charge of negative 1. Well, I want a charge of 0. So to get it closer to being 0, I need to add another positive. So let me add another Na plus. So now I have 1 plus 1 from each of my sodiums, minus 2 from my oxide, gives me an overall charge of 0. So I need 2 sodiums to balance out my 1 oxide. So my final formula is Na2O. Then my next one, I have a plus 3 charge from aluminum and a negative 1 charge from chloride. So I have 3 minus 1. So 3 minus 1 gives me a positive 2. Well, that's not 0. So let's add another negative. So now I have 3 from my aluminum, minus 1 from my chloride, minus 1 from my other chloride. So 3 minus 2 gives me 1. It's still not 0. So now I'm going to add another chloride. So 3 minus 1, minus 1, minus 1. So that's 3 minus 3. There we've got our 0. So I used 1 aluminum and 3 chlorides. So my final formula is AlCl3. Now be very careful with those capital and lowercase letters, everyone. I saw a lot of mistakes in our warm-ups where students kind of capitalized everything. Every capital letter is a new element. Now our last one, I didn't give you the charges. You had to find the charges on your own. So for Mg, you need to pull up your periodic table and find magnesium. So remember, I always say start with these first 2 columns. This is where I usually pull from. If I haven't pulled from here, then one of these guys with fixed charges. If not here, then look in the middle. But you always start with the metal. So let's look here. Oh, there it is. Mg, magnesium. So it's in group 2. So everyone in group 2 has a plus 2 charge. So Mg plus 2. Then I have capital P, capital O, 4. Well, I can look at this periodic table for days, and I still will never find PO4. If there's more than one capital letter, it's not on your table. It's on your common ion chart. So since this is on the right side of my formula, it's going to be on the right side of my chart. So let me start looking down, looking for PO4, NO2, NO3, and then NO4. There it is, phosphate, PO4. It has a negative 3 charge. So I've got Mg with a plus 2, and then phosphate with a minus 3. Now, there are 2 ways we can solve this. We have our old-fashioned way with the math, but then this is when I introduce the new trick to you guys of crisscross shortcut. But I will go ahead and do the long way here since we're not limited by a bell schedule. So I have 2 minus 3. So that gives me an overall charge of negative 1. Okay, I want more positive. So I'm going to add another Mg with a plus 2 charge. I'm going to bring this over here so I have a little bit more room to work. So I had 2 minus 3 gave me a negative 1. So now I have 2 plus 2 minus 3. So that's 4 minus 3 gives me a positive 1. Need more negative. PO4 with a negative 3 charge. Okay, so 2 plus 2 minus 3 minus 3. So that's 4 minus 6 gives me a negative 2. Okay, my overall charge is negative. I need to add more positive. So Mg plus 2 gives me 2 plus 2 plus 2, so that's a total of 6, minus 3 minus 3, so that's a total of negative 6. So positive 6 minus negative 6 gives me an overall charge of 0. So I'm going to need 3 magnesiums and 2 phosphates. Now, a shortcut that I showed you during the warm-up and later on in our notes is I can take the charge from my magnesium, my charge of 2, bring it down to be my new subscript. And then I can take that charge of 3 for my phosphate and bring it down to be my new subscript for my magnesium. So my final solution, my final balanced formula for either form gives me the same thing. Mg3 PO4 2. Now remember, because there's more than one capital letter, that's a polyatomic ion. So if I have more than one, I need to show that with parentheses. That's the difference between getting a 2 cheeseburger meal at McDonald's and getting 4 cheeseburgers, 2 sodas, 2 fries, or getting 22 cheeseburgers, 1 soda, 1 fry. That parentheses, make sure you get the right thing and make sure you get 2 phosphates instead of 1 phosphate and 42 oxygens. So be very careful with that. And also always make sure that second O in phosphate is capital, because capital P, lowercase o is polonium. That's a different element, very radioactive. But capital P, capital O is phosphate. Then your only new assignment that you had to complete in your module was the next screenshot assignment, which was the Formula Names app, a score of 20 or more. So after our warm-up, we went back to our notes. We went back to our Unit 4, Part 1 notes. And I'm sorry, guys, there was another extra slide for Part 1. It's just one slide to practice problems. So we also worked on that. And then it was our free time to work in the breakout rooms of your choice. So here we are on page 12 of our Unit 4, Part 1 notes, the criss-cross shortcut. So if I solve this the old way with math, I can see I have a positive 1 charge for my sodium minus a minus 2 charge for my carbonate. So I have an overall charge of minus 1. So I can see that I need another sodium, so another Na+. So now I have 1 plus 1 for a total of 2 minus 2 gives me a charge of 0. And so 2 sodiums, 1 carbonate. My formula would be Na2CO3. That is the proper way to solve these problems. It will always give you the right answer. However, there is a shortcut. Chemistry is all about patterns, all about recognizing patterns. Once you see patterns, you can start doing things a little bit faster. So my criss-cross shortcut says, I'm going to take the charge from my first ion, and I'm going to bring it down to be my new subscript on my second ion. And then I'm going to take the charge of my second ion and bring it down to be my new subscript on my first ion. So I bring the 1 down to my carbonate and the 2 to my sodium. So I get a final formula of Na, then a 2 from the carbonate, CO3, bring in my carbonate, and then I don't actually write the 1 because we don't really write 1 subscripts. So I get the same formula with my criss-cross rule and with my math. Just most of us find the criss-cross rule a little bit faster. So our next example works the same way. I'm going to take the positive 2 charge from my zinc, bring it down to be my new subscript for my nitrate, and then I'm going to take that 1 charge from my nitrate. Doesn't really matter about whether it's positive or negative. All I really care about is the magnitude of the charge, the number of the charge, and I bring it down to zinc. So when I write this new formula, I get Zn1 and I don't really write the ones. NO3, capital N, capital O3. Remember that second capital letter and that subscript 3? It's kind of like the lowercase n in zinc, or the lowercase a in Na. Got to have all of it. I'm going to put this in parentheses because I have more than one. So the charge of one becomes a subscript of the other. You don't need to worry about negatives. The negative doesn't travel with it. I just want the amount. It's kind of like if you've got chocolate chip cookies. If I make chocolate chip cookies, well, how many raisins are in my chocolate chip cookies? That would be 0, because if I have raisins in it, now it's not a chocolate chip cookie. It's a chocolate chip raisin cookie. It's a cruel, cruel prank to play on someone. But I can't really have negative raisins in my chocolate chip cookie. I can have chocolate chips, I can have cookie, I can have raisins, or I can not have raisins. I can't have a negative number of raisins in my cookie. So I can't have negative ions in my compounds. So any good rule has its exceptions. Now, the criss-cross rule will work for you just fine 4 out of 5 times. But if you get something like this, it's going to give you a slightly wrong answer, but it's an answer you can easily fix to be right. So if I use math is always the correct way. Criss-cross is a shortcut. If I use math, I can see that I have a positive 2 charge for my calcium minus a negative 2 charge for my sulfate. So 2 minus 2 gives me an overall charge of 0. So I don't need to add any calciums or any sulfates in order to get to a 0 charge. I'm already balanced. So I only need one of each. So my correct formula is CaSO4. Now, if I use my criss-cross rule, it's going to kind of lead me astray, because I'm going to take that 2 from my calcium, bring it down to my sulfate, make that my new subscript, and then I'm going to take the 2 from my sulfate and bring it down to my calcium. So this tells me that my new formula should be, but it's not, Ca2 SO4 in parentheses 2. This is not quite the right answer. This one is. Anytime I have a balanced ionic compound, what I really have is a ratio of the ingredients of my compound. So here I have Na2CO3. Well, that's a ratio of 2 sodium ions to every 1 carbonate. When I have ZnNO3 well, that tells me I have 1 zinc to every 2 nitrates. If I have calcium sulfate, just 1 and 1, that's a 1-to-1 ratio. So this is a 2-to-2 ratio. That's why that's wrong. It needs to be the simplest ratio. Because in real life, if this is calcium and sulfate, it's not just going to exist as 1 calcium attached to 1 sulfate. That's not how my ions work. In the real world, I get a giant lattice structure. I have calcium and sulfate, calcium and sulfate. I have a repeating 3D pattern. So if I were to count all my calciums and all of my sulfates, they just repeat, one then the other, one then the other. So I never have just calcium sulfate. I just have a huge block of it, a huge repeating block. Now, I know when I was your age, I was really good at math, but say the word ratio, and I got a little nervous. I don't want you to get too nervous. You will have ratios you need to simplify, but a ratio of 2 to 2, it's pretty easy to simplify to 1 to 1. Other ratios you might run into are 2 to 4, and that easily simplifies to 1 to 2. You might get 3 to 6, which goes to 1 to 2. You might get, I'm not sure if I've seen this one, but you might get 2 to 6, which would be 1 and 3. You're not going to have any crazy ratios you need to simplify. If you're ending up with something like 28 to 146, there were some other bigger mistakes made long before you got there. So you should never have anything that's too hard to simplify. You might get 4 to 4, which is easily simplified to 1 to 1. So my final answer here is just CaSO4. Let me cross out those wrong ones. Now, the great thing about the crisscross rule is it makes those long form ones like our warm-up a lot faster to solve. So now instead of adding one, adding the other, adding one, adding the other, I can just take the 2 from my zinc, bring it down to my phosphate, and then take the 3 from my phosphate and bring it down to my zinc. So I can very quickly get my balanced formula as Zn 3 PO4 parentheses 2. And I'm all done. Something that used to legitimately take me about a minute to solve, I can now do in 2 seconds. So next we went on to the new slide that you just clicked on. It generated a copy. It opened up Google Slides, made a copy in your own Google Drive. It was just one slide of some extra practice on naming. And we've already done our notes on naming, so just a quick refresher. You always name the first thing in the compound and then the second thing in the compound. The first thing in the compound is almost always a metal. The one exception is when it is actually ammonium. I always say you don't need to memorize your polyatomic ions since you always have that list to look at, but it's worth your time to remember that ammonium is NH4 and it's our only positive polyatomic. So your metals, your ionic compounds will always start with a metal or ammonium. But anytime you have to look up a metal's name, bring up your periodic table. I tend to pull from here the most, then over here, then in the middle. So if I start looking over here for CS, INA, MG, KCA, RB, SR, CS. Oh, CS, there it is. Now, I can't quite read it on the screen, but CS would be cesium. And then I want to find the second half of my formula. So this is just one capital letter. One capital letter means it's going to be here on the front, over by my non-metals. So O is right there. That's oxygen. So my rule is I change the ending of my non-metals to "ide." So I have cesium and oxide. So its name is cesium oxide. Now what we haven't done yet is something like this one, this iron compound. So if I look up my iron, it's right there, right in the center of my periodic table. So, oh, possible charges, see my common ion chart. Okay, well, let's figure that out. So let's go here. And I'm looking up iron, cobalt, gold 1, gold 3, iron. Wait, iron 2 and iron 3. There's more than one iron. I have to use Roman numerals because it's in the middle of the table and because there's more than one charge. Maybe this is iron 2. Maybe this is iron 3. We now have the tools to easily figure this out. There's 2 different ways to figure it out. So if this is my balanced formula, I know the charges of 2 irons and 3 oxides are going to equal to be 0. So I have 2 iron ions, Fe, with a positive unknown charge, and then Fe plus X. Then I have 3 oxygens, and I know that my oxygen is a -2 charge because oxygen has a fixed charge. All of my nonmetals have fixed charges. Oxygen can only be -2. It will never be anything else. So 1 oxygen, 2 oxygens, 3 oxygens. So I'm going to work this out the long way first with math, a little algebra here. So I have x plus x minus 2 minus 2 minus 2 is equal to 0. I know that it's equal to 0 because every balanced ionic compound has an overall charge of 0. I'm going to simplify this a bit, combine my like terms to make it a little easier to solve. So I have 2x minus 6 is equal to 0. So let's get rid of that 6. So I'm going to add 6 to both sides. That cancels out that 6. So now I have 2x is equal to 6. Great. So I know that my 2 irons added together equal 6 to cancel out the negative 6. That's good. But I want to know what the charge on 1 iron is. So let me divide both sides by 2. Cancels out the 2. And I get x is equal to 3. A little bit long, but not that hard, I hope. So my iron has a charge of 3. So that means its name is iron 3. And then my oxygen would just be oxide. Iron 3 oxide. So there's a slightly faster way we can solve this as well. 9 times out of 10, maybe 4 times out of 5, it's going to work just fine. I'm going to show you how you know if it's accurate or if it's not accurate. So this is my formula. So I have Fe2O3. Well, we just learned about the crisscross rule to balance. We can do the reverse crisscross to unbalance and find our charges. Now, this does not always work. So if I take my subscript on my iron and make it my charge for my oxygen, and I can maybe take the subscript for my oxygen and make it the charge for my iron. Now, we're not sure yet if this works or not. Here's how you know. You need to look at your nonmetal. My oxygen can only have 1 charge. The only charge my oxygen can have is a -2. So according to this, it says that my oxygen will have a charge of 2, which is correct, -2, but 2 is the important part, the number. So because this is correct, this will also be correct. So I can do my reverse crisscross to quickly find the charge of my metal. Now, this doesn't always work. Here's an example of where it doesn't quite work out for us. If I have a compound like MnO2, so if I do my reverse crisscross here, this doesn't work, does it? Because according to this, my oxygen should have a charge of -1. Oxygen doesn't have a charge of -1. It can never have a charge of -1. It will always be a -2 charge. So therefore, the charge of my manganese would not be 2. This is not correct, so this one is not correct. So here I recommend you just solve it algebraically. It won't be too much. You're just looking for x, and there's only 1 x here. Another thing you can do if you're really feeling comfortable with ratios and multiplication, I can multiply 1 by some number to make this the correct charge. So the correct charge is 2. So 1 times 2 would give me 2, the correct charge. So if I can multiply this by 2 to get the correct charge, if I multiply 2 by 2, I will also get the correct charge of 4. So you can work with multiplication in the ratios if you like, or you can work it out algebraically. And a good question I got during class today is, when do I need to do this? You need to do this anytime you get an element from that middle section of the table, also tin and lead. I usually say anyone under here as well, those metals. But tin and lead are ones you'll get that will need Roman numerals, and everything in the middle. The new periodic table that I've put in the module for this week, and also now linked in our resources page or a Bitmoji classroom, they say in the middle you need Roman numerals. Just like they handed out periodic tables from school, there's one thing that the PDF has that these tables do not have, and that is my metalloid staircase. I've highlighted it in green, so you can more easily figure out that everything over here are my metals, and everything in this corner are my non-metals. Because I realized that if we were in our classroom, there's a giant periodic table in all of those rooms. So it's like 10 feet by like 5 feet. It's huge. And on that giant table, we've highlighted where the metalloid staircase is. So you guys can always figure out the metals versus the non-metals and the metalloids. So since you don't have a giant periodic table to look at, I want to make sure you have at least that smaller one with the metalloid staircase pointed out. So we spent the rest of our class time in different breakout rooms. I was sitting in room 1. I went through some practice problems with whoever requested to be in group 1 to do a little bit more practice. I'm really happy everyone who came and worked with me in room number 1, they said they felt a lot better, and really we spent about 10 minutes because I had to bounce around a little bit more together. Room 2, all I asked is that you guys kept your mics ready so you could ask a question, and if someone asked a question and you had the answer, you could respond. And then room 3 was the sad, quiet room where everyone just worked with their cameras off and their mics off. But you were told you could always summon me as your teacher. I kind of like this model. I think it worked pretty well. It might happen again. And rooms 4 and plus were just invite only. So if I needed to talk one-on-one with a student, or if one of us teachers needed a little small group, we had it there. And we just asked that you don't choose one of those rooms. So that's what you missed in class today. I hope that everyone stays safe this weekend, makes good choices. One more class till Thanksgiving. Have a good one, guys.